Hello. My name is Humphrey Solomon Jr. Welcome to my channel. Our today's video presentation is about hyperbola in conic sections. Before we continue, please watch my other tutorials and please subscribe to my channel, thank you so much. Okay, let's define a hyperbola. In analytic geometry, a hyperbola is the set of points P on a plane, such that the absolute value of the difference, of the two distances from point P to two fixed points, is a constant. The fixed points are called the foci of a hyperbola. And the value of the constant will be explained later, please stay tuned. Let's discuss first some important parts of the hyperbola. The center of the hyperbola, the vertices, and the foci. And then, we have the transverse axis, which is the segment joining the vertices of the hyperbola. This corresponds to the major axis of the ellipse. Also, we have the conjugate axis, which is the segment that passes through the center, and is perpendicular to the transverse axis. This corresponds to the minor axis of the ellipse. And, we still have the extremities of the conjugate axis as its endpoints. In a hyperbola, we have an auxiliary rectangle. This is formed by the lengths of the transverse axis and conjugate axis. Using the diagonals of the auxiliary rectangle, we can make two straight lines as our asymptotes. These are the lines that the hyperbola will get closer and closer to, but will never touch. And of course, we have the latera recta. These are the chords that passes through the foci of the hyperbola, and are perpendicular to the line that coincides with the transverse axis. And then we have the measurements. The distance from the center to any vertex is a. This means, the length of the transverse axis is 2a. The distance from the center to any extremity of the conjugate axis is b. This means, the length of the conjugate axis is 2b. The distance from the center to any focus is c. And the relationship of a, b and c is represented by the Pythagorean theorem, where c is the hypotenuse. The length of the LR is 2b squared over a, and the eccentricity is c over a. Now, the value of the constant mentioned earlier from the definition of the hyperbola, the set of points P on a plane, such that the absolute value of the difference, of the two distances from point P to two fixed points, is a constant. Let's have a point on vertex 1 of the hyperbola and label it as point P. The distance of P to focus 1 is represented by the blue line. The distance of P to focus 2 is represented by the green line. The blue line is the same length of the other vertex 2 from focus 2. So if we will subtract the distance of P to focus 1, the blue line, from the distance of P to focus 2, the green line, we will have the length of the transverse axis as the result. The constant, which is equal to the difference of the distances from any point P on the hyperbola to the two fixed points, the foci, is equal to 2a. Next, let's review what is eccentricity. The eccentricity of a conic section completely characterizes its shape. For example, all circles have 0 eccentricity, and all parabolas have eccentricity equals 1. Hence, all circles and all parabolas have the same shape, only varying in size. In contrast, ellipses and hyperbolas vary greatly in shape. The eccentricity of ellipse ranges from 0 to 1, while the eccentricity of the hyperbola is greater than 1. Now for the equations of the hyperbola. If the transverse axis is horizontal, the quantity x minus h squared is positive. If the transverse axis is vertical, the quantity y minus k squared is positive. Note that the position of a squared and b squared did not change for both equations of hyperbola. For the general form of equation for a hyperbola, we have ax squared minus ey squared plus dx plus ey plus f equals 0. Where a and c have different signs, and neither is not equal to 0. Now, let's identify the parts of the hyperbola, given its equation in standard form. We have an example below. The quantity x minus 2 squared over 25, minus the quantity y plus 1 squared over 9, equals to 1. We can see from the equation that a squared is 25 and b squared is 9. And then, the transverse axis is horizontal. The center is 2, -1. The length of A is 5, the length of B is 3, the length of the transverse axis is 10, and the length of the conjugate axis is 6. Using the Pythagorean theorem, we can get the length of C equals the square root of 34. The length of LR is equal to 18/5. And the eccentricity is the square root of 34/5. Next is, writing the equation of the hyperbola, from general to standard form. We have an example, 16x squared, minus 4y squared, plus 32x plus 16y, minus 32 equals 0. Here, we first transpose the -32 to the right-hand side of the equation. Then we group the terms with x and y together, and factor out the 16 from the terms with x, and factor out the -4 from the terms with y. After that, we need to perform completing the square for the x and y quantities. Remember to add the same quantities to the right side when completing the squares on the left side. Then, simplify the right side to get 32, and divide both sides of the equation by 32, so that the right side will be equal to 1. Simplify the left side of the equation, and this will give us the answer. The quantity x plus 1 squared over 2, minus the quantity y minus 2 squared over 8, equals to 1. Next is, graphing a hyperbola. We will graph the hyperbola given in standard form below. We can do this by identifying first the values we need to graph. The x quantity is positive, so the transverse axis is horizontal. And the center is at -1, 2. The length of A is 3, the length of B is 4, and the length of C is 5 using the Pythagorean theorem. From here we can get the length of the transverse axis equal to 6, and the length of the conjugate axis equal to 8. The length of the LR is 32/3, and the eccentricity is 5/3. And half of the LR is 16/3, or 5.3 in decimal. We need half of the LR in graphing the hyperbola. We are now ready to graph the hyperbola. Plot the center -1, 2. From the center, plot the vertices horizontally at 3 units away, this is the length of A. Next, from the center, plot the extremities of the conjugate axis vertically at 4 units away, this is the length of B. Next, draw the auxiliary rectangle with the vertices and extremities of the conjugate axis as midpoints. Next, draw the straight lines for the asymptotes using the diagonals of the auxiliary rectangle. Next, from the center, plot the foci horizontally at 5 units away, this is the length of C. Next, draw the LR which is 5.3 units long from the foci vertically. We can now draw the lines of the hyperbola using the endpoints of the LR and the vertices. Make sure that the lines have arrowheads approaching the asymptotes. Be careful, the hyperbola must not touch the asymptotes. Next example in graphing a hyperbola. We will graph the hyperbola given in standard form below. We will do this by identifying first the values we need to graph. The y quantity is positive, so the transverse axis is vertical. And the center is at -2, 2. The length of A is 4, the length of B is 2, and the length of C is 2 square root of 5 using the Pythagorean theorem, C is 4.47 in decimal. From here we can get the length of the transverse axis equal to 8, and the length of the conjugate axis equal to 4. The length of the LR is 2, and the eccentricity is square root of 5/2. And half of the LR is 1. We need half of the LR in graphing the hyperbola. We are now ready to graph the hyperbola. Plot the center -2, 2. From the center, plot the vertices vertically at 4 units away, this is the length of A. Next, from the center, plot the extremities of the conjugate axis horizontally at 2 units away, this is the length of B. Next, draw the auxiliary rectangle with the vertices and extremities of the conjugate axis as midpoints. Next, draw the straight lines for the asymptotes using the diagonals of the auxiliary rectangle. Next, from the center, plot the foci vertically at 4.47 units away, this is the length of C. Next, draw the LR which is 1 unit long from the foci horizontally. We can now draw the lines of the hyperbola using the endpoints of the LR and the vertices. Make sure that the lines have arrowheads approaching the asymptotes. Be careful, the hyperbola must not touch the asymptotes. Next, finding the equation of a hyperbola in standard form. Example number 1, we have the vertices at positive and negative 3, 0, and the foci at positive and negative 5, 0. If we will plot the vertices and the foci, we can see that the center is at 0, 0. Also the transverse axis is horizontal. And the length of A is 3 units, while the length of C is 5 units. Using the Pythagorean theorem we can get, b squared is equal to 5 squared minus 3 squared, so b is equal to 4. Since the transverse axis is horizontal, we will use the standard form of equation for hyperbola with the positive quantity x minus h squared term. And then, we substitute the values we got previously, and the equation we are looking for is, x squared over 9, minus y squared over 16, equals 1. Example number 2, we have the vertices at positive and negative 4, 0, and the extremities of the conjugate axis at 0, positive and negative 6. If we plot the vertices and the extremities of the conjugate axis, we can see that the center is at 0, 0. The transverse axis is horizontal. The length of A is 4, the length of B is 6. Since the transverse axis is horizontal, we will use the standard form of equation with the positive quantity x minus h squared term. And then, we substitute the values we got previously, and the equation we are looking for is, x squared over 16, minus y squared over 36, equals 1. Example number 3, we have one vertex at 3, 8, the length of the transverse axis equals 8, and the length of the conjugate axis equals 6, while the center is at 3, 4. If we plot the given vertex and the center, we can see that the transverse axis is vertical. The length of A is 4, and the length of B is 3. Since the transverse axis is vertical, we will use the standard form of equation with the positive quantity y minus k squared term. And we substitute the values we got previously, and the equation we are looking for is, the quantity y minus 4 squared over 16, minus the quantity x minus 3 squared over 9, equals 1. Now, let me also share with you this helpful site I found in Google. emathhelp.net. This is a free online resource. You can find helpful math notes, equation calculators, and free homework help here. To use the hyperbola calculator from emathhelp.net, you just need to search for emathhelp hyperbola calculator in Google, then click the link here. And then, input the information you have for the hyperbola and skip the unknown values. In one of our examples, I used the coordinates of the given foci and the vertices. Then, just scroll down until you see the calculate button. Click the calculate button and wait for the answer to load. This is amazing. This can help you check your answers after you solve. Especially for self-assessment in some exercises. I hope I was able to help you learn about hyperbola in conic sections. Thanks for watching this video. Don't forget to hit the like and subscribe buttons below. Also, click the bell icon to get notified when I upload my next videos. Please share this video.